everyone. Before I start the lecture, we have still 2 minutes till 12:30. Everyone has these periodic tables. You don't have it? Tell him that I need more, because I think that is all I have. Let me check. Okay, how many don't have? Can you raise your hand so I bring next session in? 3 people, right? Can you raise your hands like higher so I see everyone? Okay, 3, right? Okay, so I'll make sure to bring 3 next session, or like more maybe. Okay, so before I start the lecture, we still have like 1 minute, so I'm going to wait till 12:30. Anyone has any questions? Do you guys want to make any announcements, or you're good? Good? Okay. So again, make sure to take advantage of SI Pass, because they're going to solve, Sydney and Riley solve problems that you see in your quiz, or like homework, or really similar problems, and also prepare you for the class. So yeah, and if you cannot attend any of those sessions, just email me and I schedule something for you. You have the advantage as well. Okay, so now it's 12:30. I'm going to start the lecture. Before I start, does anyone have any questions about previous lectures or anything in general? Okay, something that I always tell my students is that never be afraid to email me if you have any concerns about anything with the course, And I had the students last semester and also this semester for my other courses that they have like 2 exams on the same day. So if you have like, CHEM101 and some other classes that they have exams at the same day, just email me and I will schedule makeup exams for you, because I realize it would be difficult to just focus on 2 courses on the same day, and then the exams can't be back to back. So about anything in the course, feel free to email me. Don't think that this is like how it is and you cannot change anything. You can, And the same thing with like, homework assignments, quizzes, everything. If you're like sick and you cannot accomplish the quiz on the time that I assigned that to the class, I'll work with you and, write a makeup quiz for you if that's the case. Does that make sense? So never be afraid to email me. That's the bottom line. So we were talking about chapter 3, which is matter and energy. And as usual, I'm going to kind of like go through some slides that I went through last session to make sure everyone knows the materials that we talk about. So can anyone tell me what is matter? Yes?
I know a mix of everything, but I don't know the answer.
So, first of all, virtually everything that you can see, they are matters, right? So this table, lamps, the periodic table poster that you see, everything that you can see virtually, they are made of matter. And this is kind of like the most solid or like rigid example or like definition of matter, that they occupy space and have mass, right? For instance, light is not a matter because it doesn't have mass, or it doesn't occupy space in that sense. But oxygen, as we talked about, is matter because although you cannot see it with naked eye, you can see it under the microscope, and also, depending on the precision of the microscope, and also you can compress it and then put it in a cylinder. You see that sometimes when you're walking to run through a hall, you see that they have like these cylinders that filled with gases, like it can be nitrogen, it can be oxygen. So technically you can put them in cylinder, right? You can, measure their mass. So they're, in general, matter occupies a space and has mass. Any questions? So we have like different categories, right? Some of them are like visible to our eyes, as I said, like, water, steel, wood, plastic. Some of them, like, microscopic dust or like air, we cannot see them, but they are still matter. Question?
So is there no matter in a vacuum?
Yeah, so there is no matter in the vacuum. Yeah. So if you don't have like, no oxygen or anything, yeah, there is no matter in the vacuum. Great question. Any other questions? So element, can anyone tell me the definition of an element? And you have the definition here too. We can just look at it and then just give me the definition of element. Yes?
The substance that can't be broken down into smaller substance through ordinary chemical reactions.
Exactly. So we made an example of gold, right? So gold, if you have a gold ring or like gold in general, it consists of Au or like gold atoms, but you cannot convert, that gold atom with like ordinary reactions to some other element, right? So they are like, let me just like have my highlighter here, All matter is made of substances called elements which have a specific chemical and physical properties and cannot be broken down into other substances through ordinary chemical reactions. Can anyone tell me where did we put all the elements? We had a table, right? You can also point it in this room if you see, right? Periodic table, all the known elements, we put them in this periodic table. So you have like hydrogen, helium, some of these you heard before probably, right? Anyone heard of gold before? Right? Silver, you have like, sodium chloride, right? Sodium in sodium chloride is an element, sodium. Or you have like, neon, you have like neon lamps, right? So those are all your elements. So they cannot be broken down to other, or they cannot be converted to other elements over like with ordinary chemical reactions. And they have like specific chemical and physical properties. So properties of aluminum is different than hydrogen, right? Or properties of mercury is different than fluorine. Does that make sense? So these definitions are really important because they are like the foundation of the course that we're studying. So remember what was matter, what was element, and what is like the next things that we're going to talk about. So what is an atom? Can anyone tell me what was an atom? Anyone? Atom? Anyone? Yes? Exactly. All matter consists of atoms. They are like building blocks of matter. And they are like, really, really small, right? You cannot see an atom just with your eye. You cannot even see a molecule with your eye, right? With the naked eye, I guess. So matter is ultimately composed of atoms, submicroscopic particles that are the fundamental building blocks of matter. So all those elements, they are built of atoms. So I'm going to, as we progress in chapter 3, I'll tell you that some of the elements, they exist as molecules, some of them exist as atoms, but even molecules consist of atoms. Okay? Atom is the smallest identifiable unit of an element. So all elements consist of atoms, and they are like smallest identifiable unit of elements. Any questions so far? Okay. So now, what is a molecule? Can anyone tell me what is a molecule? So we talked about matter, we talked about atoms, elements. So what is a molecule? How is it different than, yes?
A molecule is two or more atoms joined in a specific arrangement by chemical bonds.
Exactly. So what does it, did you want to say that exactly?
Yeah, I was.
Yeah, can you just say it, so we kind of like.
It's two or more atoms joined in a specific arrangement by a chemical bond.
Exactly. So we have these atoms and they may bond together or like join together with different arrangements depending on what molecule or substance we have, and they form molecules. So two or more atoms joined in a specific arrangement by chemical bonds. Okay, and it can be like different geometric arrangements, and as we progress with the course, we're going to talk about this in more detail. Okay, any questions about like atoms, molecules, right? So now we want to classify matter according to their state, and we kind of like talked about this briefly, that we can have like solids, we can have liquids, we can have gas. Can anyone give me an example of solid matter?
Rock.
Rock, yes, rock is solid, right? What else?
Table.
What is it?
A table.
Yes, exactly, this is solid too, right? So in general, for instance, ice can be a solid matter, and we're going to talk about more examples, but as your friend said, like this table, or rock, they are like solid. What is a liquid? Anyone gives me an example of a liquid matter?
Water.
Water, exactly. What else?
Magma.
What's that?
Magma, like lava.
Yeah. I mean, yeah, kind of. Yeah.
Mercury.
Mercury, exactly. So this is something I most of the time ask in the exams too. So mercury, here, I cannot reach it, but the atomic number of 80, you see Hg. Mercury is a metal, but it's liquid. And that can be confusing to people because it's a metal. They think that metals are necessarily solid. I mean, this is not a metal, but kind of like, I don't know, here something metallic, you cannot see. But we have like metallic things, right? So they think that because mercury is a metal, it's necessarily solid. It's not. So remember, mercury is a liquid, a great example. And also water, yes?
Doesn't mercury have like a really low melting point? That's why it's considered a liquid? Like it could be a solid if it's cold enough?
I guess it can be, but I'm not exactly sure. I should look that up. I don't know off the top of my head. But in general, mercury, is considered to be liquid. Any other questions? Okay, and we have like gases, right? Kind of like steam, or we have like oxygen, nitrogen gas, right? Any questions here? And I ask all of you, I know, having masks can be uncomfortable, even, for me when I'm like talking, I try to shout because I'm recording the lecture. I want everyone to hear me well, but make sure to have your masks on. In a student's evaluation last semester, some students were complaining that some students weren't wearing masks and they were uncomfortable in the class, but I wasn't saying anything to them. So for the sake of, safety of you and all your classmates, I asked you to have your masks on, because sometimes, the person that is sitting next to you, they don't want any confrontation or you know what I mean? So have your masks on as a, university policy. So here we're going to talk about, the definitions, of solids, liquids, and gases. And, it might be obvious to you that, okay, this is solid, but if I ask you for the definition, it gets tricky. And I have students, especially solids and liquids, they mix the definitions, and I'm going to ask you in your homework problems, quizzes, and exams. So make sure to follow these definitions with me. So the common states are solid, liquid, and gas. And we also have like plasma and like other states, but these are the things that we deal with in this course, So in solid matter, atoms and molecules packed close together, they can vibrate and, they can oscillate in their specific places that they are, but they cannot freely move around. So atoms or molecules packed close to each other in fixed locations, although neighboring atoms or molecules may vibrate or oscillate, they do not move around each other, giving solids their familiar fixed volume and rigid shape. So remember, if you look at the solids, if you have like, piece of wood, or you have like sodium chloride, and if you look at them under the microscope, and if you have like imaging techniques that you both mentioned some of them, and look at them, they are vibrating or oscillating in their specific locations, but just that location. They don't move around, okay? They just oscillate in their place, but they're not really move around. For that matter, they have like fixed shape, fixed volume, and rigid shape. Any questions about solids? Ice, diamond, quartz, and iron are examples of solid matter. Okay? Now, we want to talk about, different types of solids. So we have two types of solids. Some of them have like a crystalline structure that they tell you what it is. The other category are amorphous solids. Any questions? I'm just like hearing questions, I guess, but I don't know what the question is. Everything's clear? Good? Okay. So, in crystalline solids, the atoms or molecules arrange in geometric patterns with long range order, meaning that they have repeating orders. So when we say long range, we mean like repeating pattern. So for instance, here we have like a crystalline solid, and as I said, any shape that if I don't put a reference here, I mean that it's from your book. If I put, it means that I took the image from like some resource. So this, image here I took from like this YouTube video here. So here you see that you have like this structure here, and it repeats itself. You see a pattern. So you have like long range order or like repeating order. And that is a crystalline solid. But in amorphous solid, atoms and molecules do not have long range order. They don't have repeating pattern. Here you have like this. Here you have like this. Are these the same? Are they the same? No, right? So this is amorphous. So examples of crystalline solids include salt and diamond. And if you look at the structure of salt and diamond, they have like repeating order. They are like crystalline solid. And we learn as we go along the course that ionic compounds, most of them have like crystalline structure, like salt, or like table salt is like sodium chloride. And the well-ordered geometric shapes of salt and diamond crystal reflect the well-ordered geometric arrangements of their atoms. So because they have like crystalline structures, because they have like long range order, because they have repeating orders, they have like a, crystalline structure. So their geometric shape, is like crystalline. And also examples of amorphous solids include glass, rubber, and plastic. And sometimes the students see glass or like when they read glass, they think that they have like crystals or like, you know, things made of glass that are crystalline, so they think that, you know, glass has like a crystalline structure, but that's not what we mean by crystalline structure. Does that make sense? When we say crystalline structure or a solid, you know, is crystalline, we mean that if you have like the geometric pattern, if you write this, they have like repeating orders, right? So don't confuse that, you know, don't think that glass is crystalline. You know what I mean? Glass is amorphous, and 90% of students get this wrong in the exam for the reason that I just stated. When we say crystalline structure, we mean that, you know, if we draw their chemical structure of the solid, they have repeating order. So glass is amorphous, the same thing as rubber and plastic. Any question about this? Yes?
What do you mean by long range order?
So long range order is repeating order. So it means that, you know, this structure here, and I have, or maybe this one was a better example. You have like this structure here, right? Kind of like ring structure, if you will. And then that repeats itself. And we call that repeating order or long range order. Yes?
So can amorphous solids still have a pattern even if it's not repeating?
Exactly, they can have pattern right here. You have kind of like, you know, pattern as well, you know, kind of, but it doesn't have a specific rule, you know, or it's not repeating itself. So they may have like, so if this structure here, you know, if you have like this and that, and then exactly this part repeats, again, it can be like crystalline. So for amorphous, you cannot predict it. You know, you cannot write it down. So here is on the left, example of crystalline structure. On the right is amorphous because it's not repeating. We can have like, you know, if you, this one and this one, if these two rings, I guess here, if they repeat, and then you can predict it, it would be again long range order. It would be crystalline. Does that make sense?
Yeah, so does every crystalline solid have that structure, like that pattern, or are they like?
They can be different. This is just an example. Yeah, great question. Any other questions? And there are like different courses on crystallography and also X-ray diffraction. So there are like the whole world themselves, you know. And there, I have like colleagues that they devoted their lives to investigate crystalline structure of different solids. So this is kind of like another course itself. But here, what I just asked you in the exam is kind of like if we have like long range order, meaning that the solid have like repeated structure or like repeating order, they are crystalline. If they don't, they are amorphous. And then the examples, you know, glass, rubber, plastic are amorphous. The other ones like salt and diamond are crystalline. This is all I will ask you. And also you should know the shape of the other one. What about plastic? Amorphous, right? Another slide here too, you know. So you have like well ordered, or like you have like one that if I show you that here, you see that, you know, it's kind of like, you know, you see like well ordered or like repeating order, right? So this is kind of the crystalline structure, but here you don't have that, right? So this is like amorphous solid. So we don't have repeating order or like long range order. Does that make sense? But I don't ask you anything beyond this. But I will ask you, is the following statement correct or false? True or false? Glass is a crystalline, has a crystalline structure.
False.
False. Or salt has an amorphous, or is an amorphous solid.
False.
False, right? What about rubber?
That's amorphous.
Amorphous, right? Or like, what? Any questions so far? Okay. Liquid. So now we talked about solid. Can anyone tell me what was a solid?
Diamond, ice cube, table,
Okay.
iron.
Good examples, yeah? So what is the definition?
Atoms or molecules packed together to create a rigid fix.
Exactly. So can atoms move in a solid?
They vibrate, they don't actually move.
Exactly. So vibration is kind of, is a form of movement too, right? So they can move, they can vibrate, but you know what vibration is, right? If I have like this pen in my hand, and I do this motion, for instance, it's kind of like in their place without they go to the other location. So if I'm an atom here, I kind of like vibrate in my place, but I won't go to the other place. Does that make sense? They don't move around, but in their place they oscillate, they vibrate, but they don't move around. Does that make sense? Any questions? Okay, so now liquids. In liquid matter, atoms and molecules are close to each other, about as close as molecules in a solid, but they are free to move around and by each other. So that is the difference. So if I was like a, atom, a mercury atom, mercury is a liquid, right? I could also go to the other, location. So they are free to move around and they are free to move by each other, right? Like solids, liquids have a fixed volume because their atoms or molecules are in close contact. And remember, they have like, their distances are really similar, close to the atoms and molecules in solid. Okay? So for that matter, they still have a fixed, volume. So if you have like water in a container, right, or in a cup, it would be having a fixed volume. It's not like that water molecules just like fill up the space. It's kind of like they are like, or like move around freely like gases. Does that make sense? So they still have fixed volume because the distance between water molecules are similar to water in ice or like solid phase. But unlike solids, however, liquids take the shape of their container because the atoms or molecules are free to move relative to another. Water, gasoline, alcohol, mercury are examples of liquid matter. And here, as I said, mercury and also alcohol. I mean, alcohol maybe is like more tangible example because, you drink alcohol, right? So, or you can, not all alcohols, but some of them, I guess. Yeah, I guess you cannot, you're underage. So, I mean, if you're like above 21, you can drink alcohol, but it's not gas, it's not solid, right? So don't drink alcohol, don't say I told you to do so. So if you're above 21, so anyway, so I guess it's just more, tangible example, you have an idea. But like mercury, again, you may see mercury in like thermometers, and then you see like the red, they add dyes to mercury so you can see that. So some of you might know that mercury is liquid, but some of you, if you don't know that, you may think that, oh, mercury is a, metal, so it should be solid. It's not. So this is like the most confusion here, mercury, I guess. And then gasoline, again, when you want to, if your car, works with gas, you just inject gas in your car, right? So that is also liquid. And water, liquid water is liquid, right? It's not like steam, it's not ice. Any questions about that? Okay. Now gas. So can anyone tell me, what was the difference between liquid and solid, or one difference? Yes?
Solid can move to one person, however liquid can move to multiple places.
Okay, so what did you want to say?
One has a definite shape.
Uh-huh. Yeah. So which one has?
Solid.
Yeah, solids have like fixed volume, right, and then definite shape. And also liquids, they take the shape of their container, right? So in which one atoms only can oscillate or vibrate? Solids, right? So now we're going to talk about gases. In gaseous matter, atoms or molecules are separated by large distances and are free to move relative to one another. So the distances are much larger. Remember, in liquid and solid, the distances between atoms are like really similar. But in gases, the distance is much higher. So we have as a fact, I mean, you know that we need oxygen molecules, O2, to breathe, right? If we don't have oxygen, we die. So in this room, we have like oxygen molecules. And you see that in each room that you go, it has like a capacity of the room, that how many students should be in the room. I mean, it should be somewhere in the room that if we have like, thousands of students in this room, people breathe oxygen, and then, we have like carbon dioxide, right, as a result of breathing. So we would be having lack of oxygen. That's why we have like, as well as COVID, that we have like, restrictions for how many people we have in the classroom. Also, we have like certain amount of oxygen in the room. Anyway, so if, we think about it, we have like one oxygen molecule, several, but one can be here, one can be the other side of the room, or one can be that corner, you know what I mean? So the distance of the molecules are like so, the distance is much higher, can be really high. And all the oxygen in this room, we can compress it and put it in a cylinder, theoretically, right? And all of that, we can also compress more and then put it like, depending on what container we have. So again, in that matter, gases are similar to liquids, that they take the shape of their container. So in this example that I was having, if we close the doors of this classroom, if you close the doors, we have like this container or class, in a sense, that we have like O2 gas in it, right? Or if you have like a cylinder here, we can put all the oxygen in that cylinder. They take the shape of the container. In that matter, they're similar to liquids, but the distance between atoms are much higher, and atoms can freely move, or like molecules can freely move around each other. Does that make sense? These things seem like easy, but when I give that in the exam, they become tricky. So make sure to read these slides word by word. And also the study guides that I posted, make sure to read them. Okay, let me have like red here. Because the atoms or molecules that compose gases are not in contact with one another, gases are compressible. And compressibility is the ability that you can compress, the molecules or atoms, depending on what element or, what substance you're dealing with. For instance, argon, neon, they are like just an atom. You have like neon atoms. You don't have neon molecule, but oxygen is O2. You have like two oxygen atoms bonded together that we're going to talk in more detail next chapter. When we inflate a bicycle tire, for example, we push more atoms and molecules into the same space, compressing them and making the tire harder. And it's kind of like the same thing as like mattress pad, or not mattress pad, air mattress, sorry. So air mattress, have any of you used them before? Yeah, you have to, put air in them, right? And then as much as air you put in them, they become like, harder and like more comfortable to sleep on, I guess. So gases always take the shape and volume of their containers. Oxygen, helium, and carbon dioxide are all good examples of gases. Any questions about gases or like anything that I talked about? Good? Are you all with me? So raise your hands if you're paying attention. Okay, good. Yeah, I have attendance mandatory in my class unless you're sick, that you're welcome. I beg you to stay home. But other than that, I have attendance mandatory because of the experience of my course last semester. You know, there were like students suffering because they wouldn't come to the class. And if you come to the class, you don't have to watch a lecture afterwards. But if you don't come to the class and then you want to watch the lectures, you know, probably you have better things to do, so you don't watch the lecture the same day, the same time, and then by the night of the exam, you have like 10 lectures that you should go through, and who wants to watch 3 hours of lecture? I don't, you know, think even people want to watch a movie 10 hours long, right? So you don't want to go through lectures like 10 hours in a row, so that would be a nightmare. So just like pay attention in the class, I simply ask you, beg you. Anyway, so now here in this table from your book, you have like properties of solids, liquids, and gases. So we have solid, liquid, gas. I'm going to ask you from this table in your quiz, next quiz, and also homework 4, quiz 2, homework 4, exam 1. So I say which one of the following does not have a, you know, indefinite shape. So which one? Right? So these two have indefinite, this one, solids have like definite. Or I say which one, in which one the atomic or molecular spacing is like far apart. Gases, right? Or like which one is compressible. Right? So just like the same thing that we talked about, it's just like in a table summarized. Make sure to study that well and ask me if you have any questions. So now I named this 1, 2, 3. I asked you to look at this for like 1 minute or like 30 seconds. So it says which image best represents matter in the gas state. How many people say 1? How many people say 2? How many people say 3? How many people don't care? Okay, so yes, this is like matter in gas state, right? Because the distance is much larger, they can freely move. And as I, always tell all my students, as long as you care about this course and you want to get an A, I make sure that happens. So the only people that fail my course are students that simply don't care. So, and I never give up on my students. Sometimes, my colleagues say, it's last semester I was like complaining that students, they don't come to the class, they don't watch the lectures. I assign so many opportunities, they don't, care. And then they were like, just, don't care. They don't want to learn. So this is not my philosophy. The only thing that I care in this class and all my classes is students to learn. And I firmly believe that if you learn, you're going to get a good grade. And simply it's not possible because we have like so many homework assignments, so many quizzes, exams. So there is no way that you learn but you get a bad grade. So just, care about the course, I guess. And I just keep reading that all the time. Okay, now we classified matter based on state. We want to classify matter based on composition. And again, as we said, we can classify things in different ways, right? So matter, we can classify them based on their composition. So here, I'm going to zoom this picture from your book. So matter, can be a pure substance or mixture. And I'm going to go through the definitions in the next slide. Pure substance can be elements that we talked about thoroughly right now. If I tell you, if I talk about argon, you know that argon is an element. Anything from the periodic table, if I just talk about them themselves, like O, oxygen. If I just say O, you know that is an element, right? So all the atoms or like elements in the periodic table. So also compounds that I'm going to, in the next slide, give the definitions. And this is, again, something that 98% of my class last semester, they were confused. I was like, which of the following classifies matter based on composition? And one of the answers was compounds, mixtures. The other was like elements, mixtures. The other was pure substances, mixture. Are you following me? So if I ask, let me here write it. Classify matter based on composition. And this is a question I'm going to ask you in your exam quiz homework. I'm just telling you right now, different versions. So A, I say elements, mixtures. B, I say compounds, mixtures. 3, I say pure substances, mixtures. And then D, I say none of the above. So which one is the answer? C, right? So I guess I just write C. But this is equivalent to, I say, elements, compounds, and mixtures. The same thing that your book wrote here. Elements, compounds, mixtures. So remember, you have pure substances that they also consist of elements, compounds. So if I tell you elements, compounds, mixtures, or if I tell you elements, compounds, homogeneous mixtures, heterogeneous mixtures, that is also correct. But if I just tell you matter consists of elements, let me highlight, I guess. If I say matter, let me do it here. Okay, it's like elements and mixtures. Is that correct?
No.
We also have compounds, right? We're just doing it, categorizing matter. So you should consider all possible combinations, right? So students confuse this or get confused. So remember, if I tell you categorize matter based on composition, you say pure substances, mixtures, right? You don't say elements, mixtures, because you also have compounds. Is that clear what I'm trying to say? Good? Yes?
Are pure substances always solid and mixtures are always liquid?
No, I mean, they can have like different states. So you have like mixture here, you have like, if you put like sugar in your tea and then you, stir it, you have like a homogeneous mixture that is a mixture but it's liquid. But you can also have like, I guess, sugar powder, right? When you grind it completely and it's powder, it becomes really similar to salt. And also grinded salt that you can only, both of them are white, both of them are really small particles, you cannot say the difference. If I mix them, you cannot see which one is which. That can be a homogeneous mixture. Yes?
So like metal alloys would be a homogeneous mixture?
Exactly. If you have an alloy somehow that you can distinguish which one is which, it would be like heterogeneous. But I think in most of cases you cannot see the difference. You have like a pot or pan that is like, nickel, copper, or like different combinations. You cannot see which one is which. So that is a good example of homogeneous mixtures. Great question. Any other questions? Okay, and here you have like some examples. As you see, you have like, gold, I assume. And then here you have like, sugar cubes. Here you have like, sweetened tea. Here you have like the mixture of oil and water. And if you ever, try to mix oil with water, you see that they don't mix, right? Because of the interactions that you have like between, oil molecules and water molecules. So you can distinguish. If you can distinguish which one is which, it would be heterogeneous. And I wrote definitions here for you, so I can expect you to know those well. Here, pure substances are composed of only one type of atom or molecule. And as we said, they can be elements or they can be compounds. Element is a substance that cannot be broken down into simpler substances, and we talked about them in the second slide, I think, right? And a compound is a substance composed of two or more elements in fixed, definite proportions. So for instance, if you have like water, the chemical formula is H2O, right? So this is water. You don't have like water molecule that is H2O, a water molecule that is like H3O, right? Water is always H2O. They have like, water has two elements, hydrogen, oxygen, that the, proportions are the same. You always have like two hydrogen atoms and one oxygen atom in water, right? Or like carbon dioxide, some of you might know that is CO2. It always have one carbon atom, two oxygen atoms. So if you have like CO, this is carbon monoxide. It's not carbon dioxide anymore. Does that make sense? And we're going to talk about compounds in more detail in chapter 4. But as of right now, just know the definition. And here I have the definitions of, different types of mixtures for you. We can just like erase what I wrote here. Okay. A mixture composed of different substances that are not chemically united but simply mixed together. So if I have like oil and water, they're not like, they don't chemically, form any structure, it's not like compounds. It's kind of like you just like mix two substances together, right? And you can have heterogeneous mixture and homogeneous mixture, right? So homo means one, right? So it's kind of like when you have a homogeneous mixture, such as salt water or sweetened tea, the composition is the same throughout, right? So if I have like sweetened tea, if I put like, I don't know, so much sugar in my tea, at some point it doesn't dissolve anymore, right? And then you can see sugar. But if I can just like put like 1 teaspoon on like, one, cup of sugar, cup of tea, and then I give you like 2 cups. One of them doesn't have tea, the other has. Or when you go, get like coffee from Starbucks or anywhere else, if you don't ask them to put too much sugar, if it's just like a small amount, if they give you by accident, if you don't want to get any sugar in your coffee and they accidentally put, you won't know until you taste it, right? Because it's a homogeneous mixture. In homogeneous mixture, you cannot distinguish the constituents. On the heterogeneous mixture, however, here you can see, here you have oil, here you have water. The composition varies from one region to the other. But here, the composition is the same throughout, right? It's not like if you mix well, the sugar in your coffee, in your tea, when you eat it, it's not like that. The first sip is just like sweeter than the second one, right? If you mix it well, sometimes it just like, precipitates if you put too much sugar, But in general, the composition is the same throughout. Any questions about this? Yes?
Let's say in the mixture, some salt or some sugar isn't dissolved. Would that change it to be considered a heterogeneous mixture if there's still solid salt?
Yes, I mean, if you put too much salt in water, or like any other mixture that you have, if you put too much and it doesn't dissolve anymore, yes, it becomes heterogeneous. Or if you don't mix it well and you can see the constituents, if you can see the salt, yes, it becomes heterogeneous. But if you mix it well, stir it well, it would be like homogeneous. Okay? So let me go to attendance here. So make sure to fill out this form, and I asked 2 questions as well. I'm not going to grade the question, so don't, feel that you shouldn't answer the question or So just write it with the best of your knowledge. I just want to know how many people learned the things that I taught. So make sure to answer the question. And if you have class that you should run right after this and you don't have the time to do this, just raise your hand. So I just get your name, or if you encounter any technical difficulty. But if you just open a browser and type this, I think most of the time the students are fine. But just let me know if you cannot get it to work. So atoms, molecules, compounds, elements, these are really important definitions, and if you have any questions about them, just email me or come to my office hours or but if you don't know what is an atom or what is an element, you will be having problem in this course, so make sure to learn them well. Anyone has problem? Yes. Okay. Thank you. Thank you.